Hi, Ani.
Hi, Janakiraman.
So, over the last maybe 10 weeks, we have looked at the idea of sensing data, right? From
Yes.
the real world analog signal. We sensed it. We were able to even bring it into a computer. So, before that, we looked at some analog computation, right? Some adder, equalizer, and all that. But then we were also able to sample it, bring it into a digital computer.
That's right.
And process the digital information, right? Do some computation with the digital information, right? So now one other very important thing in electronics, right, is to actually transmit this piece
That's
of
right.
information.
Communication.
So, communication, right?
Yes.
Exactly, right? So we have done sensing, we have done computing. Communication is the only thing we have not covered in this course. So
Absolutely.
what I have for you today is, let's say I have two pieces of information, binary 4-bit information. Okay, let's take an example, 1101.
Okay.
Okay, and let's say 1000.
Okay.
8. Okay.
Okay.
I want to transmit these two pieces of information from one IC to the other, or technically it can be from one end of the room to the other end of the room.
Okay.
Right?
Makes sense.
So, can you help me? What do you want is your suggestion?
Okay. So, let us say, so you have this in some computer here.
Yes.
Right?
In a memory.
In some memory somewhere. And you want to send it across the room.
Yes.
So, this one corner of the room to another.
Yeah.
Right? And okay, so you want to transmit the information.
Yeah.
Well, the easiest thing I can think of, so let me take an example.
Okay.
When I teach my class, there is a projector.
Yeah.
I connect a display cable to my laptop, and it just runs all the way, along the floor, up the wall, down the ceiling to the projector.
To the projector, yes.
Right? That may be an example of what we are trying to do.
Yeah.
Right? And it's all digital connections nowadays.
Yes.
Great.
So you're saying that one is a wired connection that we
it's a wired connection that we can do.
Okay.
Right? So that's the first thing that
Yes, absolutely.
hits my mind.
Right.
So basically we are going to connect now a long wire, right?
Okay.
So I'm going to represent a wire slightly differently now.
Yeah.
So let us say, okay, so this is my connection. So I'll connect it like this. I'll show it like this.
Yes.
Just to show that it's a long wire.
Yeah.
Right? Not a short circuit.
It's not a short circuit.
We don't know whether it's a short circuit,
or
not.
not.
Right? I'll show it like this.
Okay.
This is some long wire.
Yeah. And technically you also need sort of a ground line to go through. Right?
Absolutely.
So,
because it's always, potential is always reference.
Yes. Exactly.
So maybe I, instead of change, yeah, sure. So we'll take two wires like
this.
Okay. So what we'll do, okay. So I'm going to move this just a little bit up.
Yeah. Great.
Okay. So always potential difference.
Yes.
Right. Whether it's digital or analog.
Yeah.
So this is my, a long wire.
Yeah.
A pair of wires rather.
A pair of wires. So, yeah. So you can now transmit a potential with reference to some other ground level. Or
That's
whatever.
right.
Great.
That's right.
So, so how do these, so you're suggesting that now the 1101 which is sitting in the memory.
Yes.
What should I do to?
So, so let's say I start off by sending the bits one after the other, maybe from LSB to MSB.
Okay.
Right?
Fine.
Let's say I start. So first, so I'll just choose a strategy. I'll say LSB to MSB.
Okay.
That is my order.
Yes.
Okay. So if I look at this, first I need to send a 1.
Yes.
Then followed by a 0.
Yeah.
Followed by a 1. Followed by a 1.
That's the first message.
This is the first message.
Yes.
So message 1.
Yes.
And message 2
yeah.
would basically be 0,
yeah.
followed by 0, followed by 0, followed by 1. And then all I have to do is look at this backwards.
Yeah.
That.
Yeah.
So that's easy.
So that's okay.
I will just tell the computer on the other end or whatever is there on the other end to look at this.
Yes.
Great. Well, I think we also saw that this 1 and 0 are basically 2 voltages.
2 voltages.
2 voltages.
Exactly.
So I will also take a reference. I'll say that 0 means 0 volts.
Yes.
And I'll say 1 means some 1 volt or something
VDD,
like that.
Some VDD.
Some
right?
VDD.
Okay.
Okay. It could be 1 volt, 5 volt, some reference voltage.
Yeah.
Right. Okay. So now what I need to do then is to send, when I want to send a 1, I need to send a VDD.
Yeah.
and when I want to send a 0, I'll need to send 0 volts.
Yes.
So my message 1, right, will look like this. So I said that I'm going to send 1 followed by 1 followed by 0 followed by 1. Now what I'm going to do, if I were to represent it, so I need a time period.
Because yeah, earlier we had studied that when we represented an integer, we had sampled a value.
Exactly.
It was one instant of time.
That's right.
Right? Okay. So now you're saying you're going to send something over an interval of time.
Over an interval of time.
Okay.
Okay. So now that 1, I need to figure out when the next bit comes up.
Yes.
So once I have sent 1, I need to know when to expect the next one.
Yes.
Automatically that tells me that there needs to be some timing information.
Yes.
So I will say that I am going to send it over one period, let us say.
Okay.
Right. So this is some time interval.
Yes.
Some time interval t.
Yeah.
During I'll have, so let us say now I need 4 time intervals.
Yeah, because there are 4 bits.
4 bits.
Yes.
Right. So I'll call this T1, T2, T3 and T4.
But are they equal or are they?
They're all equal.
They're all equal. You're just calling them
I'm just
different
calling them.
time intervals.
Yes.
Okay. Yeah. Equal to
T.
T. Perfect.
Okay. Equal to T.
Yeah.
Some time period T.
Yes.
Equal intervals.
Yeah.
And what I'm going to do, in the first interval, I need to send the LSB.
Yeah.
Which is a 1 for message
Yes.
1. So what I will do, okay, so I'll call this 0 volts
Yes.
and VDD volts.
Yeah.
Okay. So in the first interval, LSB, I need to send a 1.
Yeah.
And in the next interval, I need to send a 1.
Yes.
And third interval, I need to send a 0.
0.
And in the fourth one, I need to send a 1 again.
Okay.
So 1, 1, 0, 1 in
Yeah.
the reverse direction.
Yes.
Great. And my message 2 looked like 1, 0, 0, 0. I wanted to send it 1, 1, 0, 1, right?
Yes.
So I have reversed it.
You have reversed it.
I have reversed it. So let's draw it the right way.
Yeah.
So because I said I want to send the LSB first.
Yeah.
Right. So LSB I have sent it 1. Then I need a 0 after that.
Yes.
Right.
Yeah,
So I have
exactly.
reversed it. So I'll do it properly this time. So 1, 0,
1.
1
1.
and 1.
Yes.
Okay. This is my message signal.
Yes.
So LSB, this is my MSB.
MSB. Absolutely.
Okay. And for message 2, LSB is 0.
Yes.
So I have a 0. So this is 0 volts
Yes.
and VDD.
Hmm.
So I need to send a 0 for the first interval.
0 for
0
the
for the
next
second
one,
interval and the
third
third
one,
interval.
last one is just
Correct.
1.
Correct. So fourth one and then last one is 1.
Okay.
I don't know what happens after that. Right.
Okay.
So this is my MSB and
Right.
my LSB.
Right.
Okay. So clearly, if I had some potential message 3,
Yeah.
that let us say was 1, 0, 1, 0 and so on.
Yeah.
That will just look like a square wave, right?
Yes.
So that will look like that. So imagine this was 1, 0, 1, 0, something like that.
Yeah.
So then it will look like this and so on, right? So now they know exactly what.
Again, the
Yes.
LSB is 0.
I'll change it. So
Yeah,
I'll
yeah.
make it 0, 1,
0, 1, 0, 1. Yes.
I'll change this
Change
0,
that.
1, 0, 1.
Yeah,
So this is
perfect.
my LSB and my MSB.
Absolutely.
Okay.
Okay.
Great. So and I'm going to send it across a wire.
Yeah.
Right.
Hmm.
Actually, I don't know what's going to happen. We should try it.
Absolutely. Right. So that's a good idea.
Yes.
So I see that you have set up some experimental, things
Yes.
here.
Yes.
And what we have essentially is, this seems to be like a very long telephone cable,
It's a telephone cable.
right? It's a
So
telephone
the
cable.
normal wired telephone that you have in your house,
Yeah.
we have just taken the cable
Okay.
that corresponds to that.
But technically this should just be a short circuit, right?
Yes, technically it should be.
Okay.
We'll
So
take a look.
I will do a continuity test
Yes.
and figure this out.
Yes.
Okay. So the the continuity test showed the beep. So which means it is actually a short circuit,
It's a
which
short
means
circuit.
it's just a wire actually. There's nothing, no resistor, capacitor that we have added.
That's
right?
correct.
Okay. And what we have done is, we have just, like out here, maybe you can draw a separate setup for that.
Yes.
Right?
So what we have done, our
Yeah.
setup looks like this. So this is my analog discovery kit.
Yeah. The
So I have
signal
my
generator.
it has two halves.
Yeah.
So this is my signal generator part.
Yes.
And this is my oscilloscope part.
Yes.
Okay. My signal generator, I have my output.
Yeah.
Which I have, we can set it to a square wave.
You can, because we are trying to send a binary
send a
wave.
bunch of zeros and
some
ones.
binary wave. Yeah.
So we can send some binary wave.
Yes.
So this is the output.
Yeah.
And we can view the input, right? So
yes.
let us say into one of the channels. Yeah. I think this has a couple of channels. We can take the output. So what we are doing now, we are taking this.
Yeah.
And so this is again we have two wires.
Yeah.
So we'll show both wires.
Yeah, exactly.
Right. So maybe what I'll do, I'll show them always together like this.
Yeah.
Right. And so something like this. Some coiled up.
It's sort of coiled up, as you can see here.
That's right.
It's sufficiently coiled up, and it's essentially a very long wire.
It's a very long wire.
Right.
So I think it's about like maybe 5 to 10 meters long. So it can go across the lab.
Across the lab. Yeah, correct. Right.
That's right. Okay.
Absolutely.
So basically, maybe we'll just show like this.
Yes.
So we have a long wire until we send it to one of the channels.
Yeah.
Right. So again, since this is a 2-channel setup, so we'll show it like this.
Yeah. Absolutely.
So okay. Yeah. It is going into this.
So both these wires actually are to a single channel.
Yes.
All right. Okay.
Yes, both wires. So the voltage and the reference. So
yes.
The voltage and the ground.
Always they go in pairs.
Correct. So this is channel 2 and channel 1, let us say.
Okay.
So I have just connected it maybe to channel 2.
So if you look at the breadboard, here I see there are no resistors, capacitors, nothing. There just bunch of connections, and essentially this wire, like you said, going from the signal generator to the oscilloscope. Right.
That's all it is.
Okay.
We know a wire is just a short circuit. We have just in fact, in all the weeks when we did KVL, KCL, we said take a wire, connect it to a resistor, wire is zero resistance and so on.
Exactly, right? So, okay, likewise I test the green wire, which is the other. Okay. I mean, so I don't see what is special about this. If you launch a signal, it should just appear at that output as it is. That's my expectation.
Yeah.
Okay.
Let's check it out.
So let's check it out.
It out. Okay.
Okay.
So maybe what I will do, we'll start with let's say 1 kilohertz.
Yes. Signal. Let's say, or you want to go even lower?
Even lower.
Let's start with some.
So I think the lowest this can do is, let's say 1 hertz.
Yeah, 1 hertz.
We'll go for a 1 hertz signal.
Yeah, 1 hertz. So this is really slow.
Really slow.
Right now, okay, great.
So let us see what happens with the scope.
We need to run it.
So, okay. Let me, okay, the offset. Okay, yes. So we need to, we need to go up maybe 1 second per division.
Yes.
That's probably what we want.
Right.
Okay.
And what we have, so what is the voltage that you have given there? Can you go back to the
waveform generator? Go back to the waveform generator. We have basically given 1 volt amplitude.
Yeah, 1 volt and 1 hertz square wave.
1 hertz square wave, right? So if I, yes, correct.
Absolutely. Yeah, and a 50% duty cycle.
50% duty cycle.
Okay.
So there you go.
Yeah. So what you're seeing here is 1 volt per division.
1 volt per division, and 1 second we have 10 seconds, minus 10 seconds to plus 10 seconds.
Exactly.
You can see this is about 1 second.
Yeah. Right.
Perfect. And I can see largely it seems to be doing this, but I can see some
interesting things, right?
Yes.
So can we just note this down? What happened, just like the earlier experiments?
Yes.
Right.
Absolutely. So what I will do, I will make a note here of a table of input frequency.
Yeah. So what all do we want to record? You want to record the output frequency,
and
amplitude,
and shape. Some comments about the shape.
Yeah, exactly.
Right? Okay. So this is my input frequency.
Yeah.
This is my output frequency.
Yeah.
And my amplitude and shape, right?
Yes.
So So we'll note down all of these.
Yeah. Okay. So you gave 1
I
hertz.
gave 1 hertz.
The output was
Output frequency is also 1 hertz.
1 hertz.
Because you can see it's 0 to 1 second. Correct.
Yeah.
So it's
right.
1 hertz.
1 hertz.
And this is what we expect. We don't expect.
It's a short circuit, right?
Short circuit.
That's all. Amplitude is 1 volt.
Okay, and this is also 1 volt.
Yeah.
Okay.
Correct.
So great. So amplitude is also 1 volt. And interestingly, the shape is mostly like a square wave.
Mostly, yeah.
Mostly, but I do see. I actually like maybe we should zoom in. And
We
see
should
what's
zoom in,
happening
or
there.
maybe we'll increase the frequency and see
We'll
what
increase
happens.
the frequency. That will also tell
that will
us.
also
So
tell us.
we'll get a sense.
Right.
Okay?
So mostly square.
Mostly square.
Yeah.
Okay.
Fine. Great. Okay. So now let's try 1 kilohertz.
Yes. So
this seems to be very similar to our low pass filter experiment that we were doing.
We were doing.
At least what we are recording
that's right.
seems to be very identical to that.
That's right.
Okay.
Okay.
So
what we'll do, let's we said 1 kilohertz, so we'll go to 1 millisecond per division.
Yeah.
Let's go for that. Yeah.
Okay.
It looks similar. So 1 millisecond, you're getting a 1 millisecond square wave.
Yes.
Okay. And you're largely seeing a square.
Again.
Largely seeing a square.
Really, right?
Yes.
So okay. So let's put that down there.
And the amplitude is also 1 volt.
Yeah. Right.
So
again we can put that down.
So one output also seems to be 1 kilohertz.
Yeah.
And the amplitude is 1 volt.
Yeah.
And we're getting a square wave.
Yeah.
Right. Nothing out of the ordinary.
Yes.
Okay. So we'll go to 100 kilohertz.
10 kilohertz.
10 kilohertz. Let's
10
do
kilohertz.
maybe step by step.
10 times. Yeah.
10 times. So now we have to go to 100 microsecond per division.
Yes.
Okay. Okay. I am starting to see something cropping up there.
Yes.
Okay. The square wave, the dark blue color line is showing something happening there.
Correct.
So we need to investigate that.
Yes.
Right.
Okay. So we'll note that down. 10 kilohertz. Output is 10 kilohertz because you change the time division now
time
to
division. So you can see 100 microseconds is the period.
Exactly.
100
exactly
corresponds to 10 kilohertz.
10 kilohertz, right?
Okay. Amplitude is 1 volt.
Still 1 volt.
Still 1 volt.
Because it's 1 volt per division.
Correct. And it's a square wave.
Yeah.
But with some
overshoot.
Some overshoot
kind of thing
happening.
Right. Maybe you put a square wave star or something.
Yes.
Right. Just to indicate it's not the same as the earlier.
Correct.
Okay. Right.
So then
now we go again 10 times, 100 kilohertz.
100 kilohertz.
Okay.
Okay. And this should be 10 microsecond per division. Oh.
Now you see this. Now I think you need to zoom in a little more.
Yeah, we don't even see a square wave.
We
are
exactly.
seeing something happening right at the edges, right?
Yes.
Okay.
So can you?
So we'll note this down and then we'll go back and see what's happening.
Yes.
So now it seems like if I wait for some time, I'm getting 1 volt.
Yes.
Right?
Yes.
So the amplitude technically, maybe I'll just put a star here.
Yeah.
It is 1 volt, but I have to wait for some time.
Yes.
Now this is not I mean, it's nominally a square wave, but something is happening.
Yes.
So we need to go in and look. So what I'll do,
time.
The time axis. So maybe what I'll do, I'll change it to 1 microsecond per division.
Yes.
We'll zoom into 1 period.
Wow.
Oh, okay. This is very interesting.
Now, okay. So this is completely counterintuitive, right?
Absolutely.
You sent a square wave.
Yes.
And we saw this kind of a picture, if you remember when we rotated that fan.
That's right.
And we actually measured, we saw a damped sinusoid output.
Correct.
Okay.
Yes.
So
this looks very similar to that.
That was because, that coil was rotating in a magnetic field. It generated an EMF, which is sinusoidal.
Yes.
But where is this sinusoid coming from?
This is interesting. So what it is doing is it seems to be kind of going up and down like a sinusoid, but it's dying out. Eventually, it does seem to be reaching the final value.
Exactly.
Right. So it seems to be doing something.
Yes.
We need to look at this.
Yes. We need to understand where this is coming from.
That's right.
Right.
Okay. So what I will, what do you suggest we note it down as?
This is square wave with some damping sinusoid. I don't know.
Yeah.
Right?
Maybe we'll call it ringing, because it sounds like if you ring a bell, right?
Yes.
It's loud for some time and slowly it loses
Slowly
like a cycle bell.
Exactly.
Right?
So
We
I
just
think
call it ringing.
Ringing.
Right? So it's a square wave
with ringing.
Okay.
Okay.
And I'm guessing that even if I go to 1 megahertz, I'm going to see something similar.
So we'll just
we'll just record one more point.
1 megahertz.
We'll record a 1 megahertz point, and then we'll come back and see why this might be coming. So this is 1 megahertz, and okay, let's see what's happening here. So this is, it is giving us 10 periods. So let us see, wow, this is doing something crazy.
This is completely crazy.
Completely crazy.
Right?
So this is cannot even be called a square wave.
Yeah.
Right?
Exactly.
So clearly what my interpretation, so we'll note this down, right?
Yes.
Now I do see that it's periodic.
Yeah.
Right?
It is repeating.
It's repeating, but I don't know what it is.
Yeah.
So it seems to be repeating every 1 microsecond.
Yes.
We can do this. We don't know what this is.
We don't know what the shape is. Yes.
Actually, what this is telling me is that the interval matters a lot. This T, capital T.
Exactly.
Right? It seems like if I try to send something with a very short T, very high frequency, I really cannot send it.
Over a wire.
Over a wire.
Exactly, right? So this seems to be a big problem.
Yes.
Right?
I can send it very slowly.
Yeah.
Right?
You can send
so
it.
Which means distance, if it were maybe 10 meters, looks like I can only send it till about 100 kilohertz.
Exactly.
Right?
Right.
If it were maybe shorter distance, maybe I might send it more.
Faster. Yeah.
Yes.
Right?
Maybe we'll have the students measure that when they get their kit.
Yes. Absolutely. Right.
Okay. So maybe we need to find out why we are getting this.
Yes.
Right?
Absolutely.
Because let's refresh for the students.
Yeah.
When we actually sent some periodic signal, let us say a sinusoid through a capacitor.
Yes.
Right? Through a low pass filter.
Yes.
Right? We sent some V sin omega t and we looked at the output, which we expected to be some VO
sin
omega t plus phi. Something like this is what we got.
Yeah.
And when we plotted VO by VI as a function of omega. Right? So, and this was VO by VI, the magnitude.
Amplitude, yeah. Correct.
Right? So, output amplitude by input amplitude, we saw that it was 1 for very low frequencies. DC. But then it kind of went down like this, slowly like this, right?
Yeah.
So, at some, I think, magical value, so this is 1, 2, 3, right? So, somewhere here, let us say.
Correct.
At 1 over RC, it went to 1 by root 2. 1 over root 2. Okay.
Right.
Right. So we know this, and we also saw that if we gave a square wave or a step, what would happen?
Yes.
Right. And we saw that we took the same circuit, and if we actually gave, let's say, a step voltage, we saw that the output voltage, so this is V in, we saw that this voltage actually took some time to respond. Yeah. It went up as an exponential.
Yes.
But if you wait long enough,
you would reach
the final value.
So,
right. So this goes from, let's say, 0 to 1 volt. This will go from 0 to asymptotically, it will hit 1 volt.
1 volt. Absolutely.
Right? Okay. So we have seen, I don't think we ever saw like a ringing, sinusoidal.
Yeah, there was no sinusoid.
Right. When you gave an input step.
Right. At most, the square wave was distorted.
Correct.
And if it was very fast, it never even got to 1 volt. It would go all the way to like 0.5 volt and then discharge.
That's right. So if you gave it a very, very fast sinusoid, right, something like this, so it would basically give you something like this, right? So maybe something like this.
It has enough time only to charge to. Exactly.
Something like this you would get at the output.
That's at most what we got.
That's right.
But we never introduced a new kind of signal into this.
That's correct. In fact, you expected the output to only give you the input frequency, right? So you gave some period corresponding to something, right? So you wanted, so what we saw was when we gave 1 hertz, the output time period was also 1 second.
Exactly.
Now we are seeing some sinusoid with some different time period in it.
Yes, there
Right?
seems to be some, but it is still, it's repeating it
It's
at,
repeating.
at 1 hertz.
It's repeating at 1 hertz.
But
the
there
overall.
seems to be, it seems to be superimposed with something else.
That's correct. So we are still, so let's go back to that 100 kilohertz,
100 kilohertz,
input, and we can see it very clearly.
Look at that.
There you go.
Right?
So every, if I actually make
Zoom out a
this
little
zoom
bit.
out just a little bit. Okay, one
Further.
more, maybe two, we'll
Yeah.
show them two. This will show us the periods.
Yeah. It
Right?
is repeating.
Everything is repeating about this.
Yes.
The ringing is repeating, and the overall you're also seeing, you know, your input time period as well.
Exactly. Right. So also it's interesting that when this output is rising,
Yes.
it is overshooting,
Yes.
and when it is falling, it is going way
Undershooting.
below.
That's right.
Right.
Instead of -1, it is actually going all the way to almost -2.5 and coming back up.
Right.
Same way on the upper side, it's going all the way to +2.5. That's right.
Right. So this is because this also is very counterintuitive, because if we had a 1 volt source, we have made statements earlier that the output cannot go higher than 1 volt.
That's correct.
Right. These were one of
That's
our checks in the resistive circuits that we did.
That's correct. So
Right.
because we always expected it all the way to reach 1 volt or stop short.
Stop short, never overshoot.
Never overshoot.
Right. Now we are going above VDD, going below ground,
Going below ground.
and significantly.
Yes.
Okay.
Correct.
So somewhere we have to explain this energy source also.
That's right.
Right.
That's right. Okay.